I am going to start us with just a couple of slides, but most of this presentation today is going to be live in 5. So um, you'll see here just a little bit about me. Um, I have been with AMP Software since May of 2022. I am a trainer and technical support specialist. Uh, I was a forensic scientist with the Texas Department of Public Safety in Austin, Texas. Prior to that, I focused in photography, video analysis, and audio analysis when I was there. My background is a bachelor's in crime law and justice from Penn State University and a bachelor's in photography, focusing in biomedical and forensic photography from a small school in Miami, Florida called Barry University. I am a certified forensic video examiner through the International Association for Identification. I am a certified forensic video technician through LEVA, the Law Enforcement and Emergency Services Video Association, and of course, an AMP5 certified examiner. I am in the OSAC. Man, there's a lot of acronyms on my slide. I apologize for that. The OSAC is the Organization of Scientific Area Committees. And the committee that I'm in is digital multimedia, which is then broken into subcommittees. And the subcommittee that I'm in is VITAL, which is the Video Imaging Technology and Analysis Subcommittee. And I am the chair of the Image Analysis Task Group within that subcommittee. So just a random fact about me, I recently started mountain biking and I am not good at it. I'm really good at falling off of my bike. But anyway, that's just something fun about me. So if you are going to be following along at home, you don't have to. You could just sit back and relax and watch what I have to show you. But I'm going to make a few changes right off the bat. So I just wanted to document those here so you know where I'm going. I'm going to change a few things about the 5 GUI. Well, first, I already put it in dark mode. Hopefully, that'll be a little bit easier for you to see on your screen. Um, and I'm going to move my player bar. We're not going to be dealing with any video in this particular webinar, so I am hoping that by moving the player off the screen, it'll give me a little bit more space so you can see the images a little bit better. And I'm going to change a couple of program options. One is just a convenience thing. I'm going to be making a lot of copies of my chains, and there's a message that prompts up that asks you, do you want to automatically rename the chain the same thing? And I don't need it to ask me that every time because I just want it to do that. So I'm going to change that right off the bat as well. And I'm going to change my default image format because the default in the software currently is JPEG, and I don't want it to be a JPEG. And we'll talk more about that towards the end of the presentation. But I am going to change those things first off. So let me return back to 5 and make those changes. So the first thing I'm going to do, if you've never moved one of the panels in 5, I'm just going to grab the top bar of the player here and just move it to my other monitor. That way I have a little bit more space. And again, I'm doing that because we're not going to be dealing with video in this particular presentation. We're just going to be dealing with still images. And that's going to give me a little bit more space to work. The other things are in the program options, which are here in this gear at the top of the software interface. The first thing I'm going to do is change this JPEG. I'm going to put it in a PNG, and we'll talk more about that later, but that's going to be my default here. And then in the import tab, I'm going to change this auto rename chain on replace loader. Instead of always ask, I'm just going to say yes, just change it for me. And then hit OK. So that's just the 2 things that I'm doing to get set up to start, just so that we hopefully have the best opportunity here. I guess there's one more thing I'm going to do. I'm going to probably close my bookmarks panel here by hitting the little X. I will show it to you again a little bit later, and I can always turn it back on in my view menu by checking the bookmarks panel here, and it'll come right back. So, okay, I have a couple other slides. I'm going to be going back and forth the whole time. So I hope that that is not going to be too disorienting. Maybe I'll give you a little warning before I do it each time. So we're going to be focused mostly in this space of the ACE-V method. So this ACE-V method stands for analysis, comparison, evaluation, and verification. So this is the tried and true methodology for when you're performing comparison work. You want to analyze your latent print or your subject matter, whatever it is. You want to then compare it to other known um, images of your same object. Then you want to evaluate, determine, can you say these things are the same or that they came from the same source? And then you send your entire work product for a verification from another qualified examiner. Okay, so the first step here obviously is analysis. And I'm going to remind everybody, if you've been to our AMP5 main class, this image is probably familiar to you. This is a diagram from our image generation model. So what this is, and I've put the references down below, both a blog post where we explain this image generation model, as well as the white paper that we published where this image is represented. And maybe I didn't give these to you in advance, Michelle, but maybe we can put these in the chat or I can put them in there a little bit later. Um, this is this webinar is not going to be talking really about surveillance video at all, and that's the real basis for this plan. But I want this mindset to be with you. What we're doing by doing these clarifications or enhancements is attempting to undo the defects that have been applied to our imagery and reset us back to what is the closest to the original scene. So if it's a latent fingerprint, we're trying to get back to that original finger, right? That's what we want to do. We want to take away the distortion and the other elements that have been introduced throughout the generation of this print and this later image. Um, and so it's the same kind of idea as what we have with our image generation model, where things pass through each step in the chain and different defects are applied to our image throughout the process. So we're going to be with a similar mindset um, here. Okay, so again, analysis, right? So our first step to analyzing an image is being able to visualize it. And typically, I'm going to do some adjustment type things for clarification. But in this instance, I'm going to show you some geometric processes that we might do just because I'm going to be utilizing those right off the bat. So some examples of these are cropping and rotating, very simple edit functions. In fact, I'm not even going to do those in the software really quickly. I'm just going to show you an example. So you can see on the left-hand side, we have multiple uh, fingerprints in one image, and the image is turned to the side. So very simply, I rotated and then cropped each one of those so that I can analyze them more closely. I know exactly which one I'm referring to when I'm looking at a specific digit because I can label them independently. And then from there, I can continue with my analysis and everything is very clear and easy to work through. So that is important because once we get into some of these examples, I will need to rotate them so that it's a little bit easier for us to visualize throughout the explanation here. Once we have oriented the image, a lot of times we'll be facing a situation where we can't see it, right? So maybe it's too dark or there are other details that keep us from being able to visualize and interpret and fully analyze this image. So this is where we're going to start with some color, saturation, and contrast things. And I have just a few more points I want to point out before we go to the examples. The first is just a quick discussion on color space. So when we view color images, they're in this typically a red, green, blue RGB color space. Okay, and when we are viewing things, it's not necessary to invent every single color. We can just use a combination of these to recreate the colors that our eyes can interpret. In general, Our eyes see the most detail in the green channel within the color space. So we see that the calculation of the values give the most priority to the green channel within that color space. We give almost 2/3 priority to green. We give about a third priority to red, and then just what's left over to blue, very little, because we don't see very well the detail in the blue channel. And as an example, again, this is not going to be a class dealing with surveillance video predominantly, but I like this example because even just splitting out this one color image into the red, green, and blue channels, you can see very clearly the detail in the green channel, and it's very difficult to discern detail in the blue. So this just helps to solidify the fact that we're going to see a lot of detail in green that we're not going to see in blue, and that's going to be relevant to us here in just a moment. So to the examples. All right. Let me make sure I open the chat so that if there are, oh, good. Thank you, Michelle. She put the links in there for us already. That's great. Okay, I just wanted to make sure in case somebody sends me a question that I am prepared for it. So let's start with example number 1. Here we go. I will be using a lot of very large images. So you can see down here in the bottom bar of 5, this tells me that this is an NEF extension of an NEF format is a Nikon RAW image format. And the resolution is 5600 by 3728. So it's a very large image. So a lot of the processing that we're going to do might be a little bit slow. So bear with me, but that's because we're using the high quality image and we're not sacrificing any detail in order to be able to see all that. So, okay. So we can tell that there's likely something here of importance, but it's very dark. It's hard to see if there's any information that we can glean from this fingerprint. It's hard to analyze it. So we might need to do some adjusting. So adjust is the filter group that I'm going to start with. This is where a lot of our color, contrast, those types of things exist. Now, I'll stretch these out a little bit so you can read everything that we have in here. There are lots of different filters available. And as they say, the nice way is there's more than one way to cook an egg. I Googled it to have a nicer phrase to say today than the typical common one. Um, so there are lots of choices of things that we can do here. I like to start with levels because it is my personal favorite because it uses something called a histogram. And we can view the histogram also down here in the tools panel. And let me pop this panel out so that we can see the whole histogram and I can walk you through what we're viewing here. So a histogram is essentially a bar graph that shows us all the values in our image from 0 to 255. So we have those red, green, and blue channels can combine in this type of image to represent 256 values, 0 to 255. 0 is the blackest black, and 255 is the whitest white. So then this graph will show us the pixel representation within our image in that range. And you can see that most of the content of this graph is down here on the left-hand side, which is towards the 0 end, which is the black part of our graph, right? Which makes sense when I look at my image. I'll pop this back in over here so that we don't have it in our way. When I look at my image, I have mostly dark pixels. I don't have very much that is bright at all. So again, I'm going to close my bookmarks panel to try and give me a little bit more space here. So when I use my levels, what I can do is say, hey, all of my graph values are down here on the left. I only need to use that span of my graph to represent all of my 256 values. I don't need to use this area that doesn't have any available pixels. So I can grab my highlights slider and slide it over to dictate what part of this graph I want to use. So by bringing that highlight slider down, I've now said only use these values, but spread those out so that I can use all the variability that's possible within this range. And by doing so, it gives me a lot more detail that I can now see because I've told the software, bring some of this white area to be white. All right. So that's just one option within the adjust group. There are lots of options that do similar things. If I want to try another one and see how it looks, I can grab this image loader that I've loaded in here and drag it down until I see a blue line and make another copy of my image here. And I'm back to where I started. And I could do something like histogram equalization. So remember I told you this was a histogram. So histogram equalization is going to do an automated process similar to what I just did with the levels, but it's just going to equalize that histogram all the way across. And when I do that, you'll see that it does a similar thing, but it looks a little bit different from the one I did manually. If I go back to the one with levels, you can see that it is a little bit brighter and a little bit more evenly distributed. And I'm going to do one more just so that you can see a comparison. We introduced, I believe last year, this filter called Smart Adjust, and then we put it right here at the top because we think it is pretty darn cool and it does a really good job in a lot of instances. So if I use Smart Adjust here, you'll see the default mode for Smart Adjust is equalization, which is similar to the histogram equalization, but it does it in a slightly different way. And this one is not quite as extreme as the one that I saw with the automated histogram equalization, but it is a little bit more balanced than the one that I did manually. If I wanted to compare all three side by side by side, I could grab each of these tabs in my viewer and pull them out until I see a blue area light up. And I can drop these side by side by side. And I can view each one. I can stretch these panels around a little bit. And I can view the ridge detail in each one and see how they're different. So you can really see the clarity that has come out with that Smart Adjust. So that's going to be a filter I'm going to use quite a bit. Sometimes I think I like the way that other filters work too, but we give you all these options because, as I said, there's more than one way to cook an egg. So you can do it any which way makes you happy and which way you feel comfortable explaining, because a lot of this, the whole goal is to end up being the expert who's brought this evidence to court, right? That's the whole goal. So the end result might be you testifying to these results. So I'm going to put these all back into one viewer by grabbing these tabs and making it so that not a whole area like this lights up, but just that top bar lights up. And I can drop these right back into that top bar where they used to be. I'm going to pick the Smart Adjust one because I like this one the most. And I'm going to bookmark it for later. So if I want to bookmark something, there are a few ways I can do it. But the easiest way is going to be mark it with my M key on my keyboard, the letter M for mark, and I will M. And you'll see down here that says bookmarks updated. If I wanted to view my bookmarks panel, I can see that that Smart Adjust bookmark is on here now. I can rename it if I want by double clicking it, and I can call it 1 because this is my file number 1, and I want to remember that that's file number 1. Okay, I see in the chat there's a question. If you use Smart Adjust, how do you explain what has been done in court? That's a good question, and it's a little bit of an aside from where we were going, but I'm going to use this opportunity to point this out anyway because I can. So if you want to get some information about any of the filters, we'll see them a little bit later, but I'm going to show it to you now. There is a filter reference guide here in the help menu. If you open the filter reference guide, it will obviously open on my other monitor, and I'll bring it over here. It's very easy within the filter reference guide to find a filter by doing a Control F or a find in the document. And I can type Smart Adjust right here, and it will take me there. And this description will tell you exactly what's happening in a nice, easy to explain detail screen here. It will document, it will explain what the parameters do. It'll tell you when is a good time to use this filter, and then it will give you the white paper reference for the math that is implemented in the filter. So all of this is here so that you are able to testify to these results confidently. You can see everything about what the filter is designed for, and all the math will be explained in this article if you are uh, so inclined to read it or provide that to the court as well. Fantastic. Okay. And to clarify, Sohaila, I think the Rittenhouse case wasn't specifically about smart adjust, but it was about testifying to a filter that was used. So this is um, it's important to be confident in your filters for sure, but it's also important to know where the information is that is available to you so that you can properly explain the processes that you have performed within your analysis. Okay, fantastic. Let's see. I bookmarked this, but sometimes there's another thing I might bookmark it again in a second because a lot of times this color information can be distracting when trying to perform an analysis or a comparison of the ridge detail in an image or whatever feature you might be looking at. So we do also have the option here within channels to convert this to a grayscale image. And this eliminates the distracting element of the color so that you can focus just on the ridge detail. So I'm going to bookmark this again by hitting my M key, and I'm going to call this, double click and call it 1 grayscale. All right. Let's look at my next example here. Number 2. In this example, the first thing I'm going to do is keep my head from having to go like this, right? I'm going to rotate. So again, the rotate is an editing function. So it's in the edit group, and we have rotate here. Within the rotate filter, let me close my bookmarks panel again to give a little more space. We have these really convenient buttons for you down below where you can rotate 90 degrees clockwise, 90 degrees counterclockwise, or 180 degrees. I highly recommend you use those buttons rather than just trying to turn an image. Unless your image doesn't fall within those parameters, then that's why we give you the option to slide to whatever angle you need. But for me, 90 degrees clockwise will do it. So now this image is pretty dark. I might look and see what else I can do to brighten it up. I can do any of the adjust functions we've already talked about or any different one. I'll just stick with levels for now because that is my go-to, again, because I know a histogram really well and I know how to explain what I'm doing with the histogram very simply. So I will take my highlight slider and bring it over to where it meets the information that I have in my pixel values up here, and I've already made it significantly brighter. You can see in the histogram, I also have a small gap. Maybe it's easier in this histogram. I have a gap towards the 0 end of my histogram as well. This tells me my minimum value is 9. So I can bring this shadow slider up a little bit too to bring a little bit more, to bring my dark values here closer to black. So now I am reaching 0. Dock this back in there. Now that I have brightened this image up, it has a little bit of a yellow cast. My guess is that this was photographed under a natural light instead of some type of uh, color balanced light. So maybe an incandescent light, or actually it's a little green. So maybe even under fluorescent lighting, just visible light. So I can rebalance this so that white in the image is white. Um, a camera can sometimes be fooled by the lighting scenario. So using a sorry, see, I get distracted by the chat. I should just keep focusing. Uh, the camera can get distracted by the lighting information and shift the color a little. So we give you this white balance filter here so that you can rebalance the white point within your image. It will automatically use the whole image to inform this recalibration. But if you wanted to select a specific area, you can always go to the selection tab and dictate exactly what opportunity is used for the calculation of this white rebalancing. And yes, thank you for answering that question, David. For Tabitha, the information from that filter reference guide does populate in the report, and that's when we'll see it a little bit later. So I'll be sure to point that out towards the end. Okay, so this one I'm going to leave for a second because I have another function I'm going to perform with it. But I want to do a few more of these color and contrast adjustments before we get to that. So let me leave that one for just a moment before I bookmark it. I'm going to go to my number 3 here. Apparently zoomed out as I was doing that by mistake. Okay, so this one has a few issues. Number 1, I might start with that rotate again. In this instance, I'm going to go the other way, 90 degrees counterclockwise. All right. In this example, my process might change depending which image I was wanting to, or which ridge detail in this image I was working toward clarifying. So if I were focused on this one over here in the lighter area, I might do a crop and crop into this area here, just so there's no confusion about which image I am comparing with. And then I might do something like uh, the white balance as well as we did in the other example to make the that incandescent light effect no longer influencing my color information. Or I might want to grayscale if I am not interested in this red down here, but I don't know that that's really necessary uh, in this particular example. Now, if I wanted to deal with the other image, let me grab my image loader and bring that down so that I have a second copy of this image. I still want the same rotation, so I'm going to bring that rotate filter down as well, and it will apply the same settings since I'm just copying the same filter down. If I'm interested now in this, the ridges that are in this red area of this frame, I could crop it again just to that area. And in fact, this time I might include the scale. It's kind of nice to have the scale in there. All right. And when I'm trying to clarify this now, I have a few options. Um, My personal favorite, a thing that I've been using quite a bit lately, is now within the extract filter group, and it is the channel mixer. So we know that we're dealing with red, green, and blue channel information. And since we have a large concentration of red in this image, it actually works very nicely to turn on this channel mixer and to filter the amount of red that we have present in this image. So if I filter out my red by increasing this uh, value here, now I no longer have that muddy interference of the red. I'm working with a grayscale image that is much clearer in the ridge detail here. So to address the question of rotating with a shift of pixels, that's why I highly recommend you use those preset buttons that we have in the rotate. Let me just double click on rotate so I can bring those filter settings back up for you. If we were to use an angle that's not just rotating the pixels, it would involve interpolation, which in fact was the point of contention in the Rittenhouse trial. Interpolation has a very mathematical and technical definition, but I like to consider it this. If you have two known things, and now you have space in between them, you need to mathematically calculate what goes in between those two known things. We can't just make it up, right? It has to be mathematically calculated. So if I take my square pixel and I turn it on an angle, now it no longer fits within the confines of a square pixel, which means I need to calculate the information in order to make that pixel represented within now multiple pixels. So using these buttons allows you to just rotate the pixel and it will maintain the value without changing or having to calculate anything to properly represent that detail. So, okay, so after channel mixer, this looks really nice. I'm actually going to save this one for a later process as well. But that is a really simple way to filter this one down and remove that red effect. Okay, let's look at number 4. Okay, this one very obviously is difficult to see. We don't even know that anything is here. So I might try a few other adjust filters that we haven't talked about yet, just to see some examples of some other things we can do. So the Smart Adjust filter we talked about already. This is a really nice one. It uses a similar kind of math to this CLAHI, which is a contrast limited adaptive histogram equalization, but it does a little bit better job. But anyway, this is another option that's here. So I'll show you this one. It's similar to the histogram equalization that we performed before, but it's looking more specifically for contrast points. So by finding these contrast points, it then can emphasize the difference between light and dark, which is why it makes it so nice and bright. Um, and it gives us lots of ridge detail information that we obviously didn't have access to before. So I'll show you a few other examples of some adjust filters that can perform similar effects to bring that latent print to life for us. You might just say, well, the exposure is really low in this image. If you've ever been a photography person, I told you I have a background in photography, you know that exposure is the balance of light that we have in our image. And clearly we don't have a balance of light here. So when I go to exposure, I can just increase my exposure and make it brighter as if I took the camera picture brighter than I did. So something like this maybe, and offset it a little bit more to make it brighter. And now we've got the ability to see some information that we didn't have before. Now, it's a little bit difficult to see because this is a photograph of a print on a mirror, I think, so we have a little bit of a um, replication, which we could deal with, maybe a different way, but at least now we're able to visualize those ridges that we weren't able to see before. We could also do, I've mentioned, we've done a little bit of histogram equalization before, but I want to show you that with histogram equalization, the default will be to use, again, the entire frame for reference points. But when we look at our original, so I can either click back on my image loader here in my history panel, or I can hit this show input button and it will show me the input to this filter before the filter is applied. Where this ridge detail is and where the scale is have different values, right? The scale is nice and, well, it would be white and the print is in this dark area. So it might be helpful in my histogram equalization filter to instead use a selection. So I'm going to go to my selection tab. And you can see here the default is the whole image, but instead of the whole image, I'm going to draw a box just where my print is, and it will recalculate the values just using that area to determine what histogram values are present. So we're not skewing our values anymore using the scale as well. And in fact, since this area is brighter at the top, I can even turn this down to the lower area and it'll make it brighter. But including all of that information gives me some good clarity in some of these ridges. Some of the print's not the best quality, but we do the best that we can with the images that are provided to us, right? Once we have it nice and visible, we can look at different channel information. Uh, I explained to you already about the red, green, and blue channels, and the fact that sometimes when we look in the different channels, we can see different amounts of detail. So I've just gone to extract channel here in the channels filter group, and you can see that we can view the red, green, and blue channels, or we can convert it to a number of different color spaces so that you can visualize the detail differently. But here, uh, this is a really nice example to show you the difference between the red, green, and blue. So specifically in this top area where we do have some ridges we can view in the red channel, if I just click there and then hit my down arrow key, now I'm looking at the same pixels but in the green channel. And when I switch to the blue channel, you can see that I lose a lot of that clarity. So a lot of the detail information is kind of muddied by the blue channel. So by viewing the detail in just the green or the red channels, I can see a lot more clarity in the details, the minutia of this print than I could when the blue channel is interfering. So I might keep the green channel here, and I'm going to bookmark. So again, I'll hit my M key. My bookmarks are updated. If I wanted to rename that, let me turn my bookmarks panel back on, and I will call this one number 4. All right, I'll turn that back off so I have all of my filters I can see. Fantastic. So let's look at my next example then, which is number 5. We are, okay, just checking my time. I'm doing okay. So here's another one that is really nice for using that channel mixer, again, because I'm dealing with red and I know that I can turn down the red. So if I go to my extract and my channel mixer, here I can adjust my red by, by filtering that one and bring my other filters down a little. And now my uh, latent print clarity is quite a bit improved from where I started. So again, the show input button will show me where I started. So I had these lines that were obscuring, which we can address with a little bit different filter in a minute. Um, and I had the red, which was making this hard for me to interpret. And now that I have used the channel mixer, I can see, these ending ridges, I can see these bifurcations, I can see the ridge detail that I couldn't see before. Okay. We also could view it like we did the previous one where we extract the specific channels from the channel group, extract channel. And that does a similar thing as well, where we can cycle through and view that red, green, and blue and see how different they look. And this red, when we extract the red channel, it allows us to do a similar thing and see that ridge detail nice and clearly. Okay, great. I think I have one more example and then I have a slide that I'll pop in here. So let's look at number 6. This is another one where I might like to try that channel mixer. Telling you, lately that's been one of my go-to filters. I just really am enjoying the ability to filter the color channels specifically. So if I mess with these a little bit, I can actually filter out the distracting colors from the background and then turn my value constant up to bring just the overall brightness of the image up. And now I have filtered out a lot of those dots, those lines, the background information, and made a lot of this ridge detail much more clear for me to see. So again, show input to see where I started. I was very obscured behind this patterning here. And once I hit apply, I can now see a lot more clarity here. I will return to this one in a little bit as well. So I'm going to put up just one more slide here to kind of transition to the next little topic. Put too many things in front of my slides, so let me fix that. Okay. So uh, once we have addressed color and contrast, so now we can really see that there are ridge detail is present. We might move forward now to addressing the frequency information. So frequency can be addressed in a handful of different ways, but some examples that we're going to talk about here are the homomorphic filter and the Fourier filter. So we'll be talking about frequency information visually and in the frequency domain. So that's the only slide for the moment. Now, let me look at number 7 here. So here's one, I'm going to flip it first. So I'll go in my edit and I will rotate. And this time I can use that 180 degrees. So now it is right side up, so I don't have to think about everything upside down. This is going to be a great example for the homomorphic filter. Okay, so homomorphic filter is really special because it allows you to adjust separately the high frequency and the low frequency contrast. It has a default that sometimes does a great job on its own, but I'm going to adjust it a little bit to show you what these things do. So the alpha kind of makes it overall bright or not. Sometimes the brightness of the alpha is a little bit too much, but if you turn it down, it ends up being a little bit muddy, right? So I turn it down just a little bit sometimes. Again, oftentimes the default is great. The low frequency contrast is going to be our general shapes, you know, low gradation from dark to light areas, but not a whole lot of influence on the fine detail, okay? So in this instance, we want the low frequency contrast to be a little bit lower than it was in the original, just because the muddiness of that image was taking away from the clarity of the ridges. The high frequency contrast is going to be the very fine detail and the sharp edges, the differences, the lined differences between light and dark areas. And so having this a little bit higher is going to emphasize the contrast of where those the ends of those ridges are. Okay, so all of the edges of those are going to be a little bit sharper. The gain is overall brightness. So I could turn that up a little bit, but I don't really need to do a whole lot there. It looks pretty good now. And again, to remind you where we started, here's my input. You can see it's just a little bit gray, and there's a lot of influence on this dark area here, and there's not a lot of clarity in between those ridges. Once I apply this difference between the low frequency and the high frequency contrast, now I can see a lot more of the contrast points between the background and the ridges, and it's a lot more clear. I have another, oh yeah, let me bookmark this one because I'm not going to come back to it. So I will hit my M. Yeah, Eleanor, the difference between the brightness with the alpha and the gain. So they're just calculated a little bit differently. This one has to do, uh, you can see it makes almost like a glow versus this one makes just all the pixels evenly brighter or darker. There might be more detail about that in when we see it in the report. So I will make a note to return to that when we get there. Make a mental note because I'm not making an actual note. Let me put this on my bookmark. So I hit my M key and that is bookmarked. And I might want to call this number 7. All right. Oh, we're going to do the FFT next. You are right on top of it, Fabio. So I actually have one more homomorphic filter I want to show you, and then we will do the Fourier. So this one I handle a little bit differently. I'm going to rotate this one to the right, clockwise, and you can see that this one is a shoe impression. But if I zoom in here, you can see that it's kind of gravel and sand, and all of this little information is high frequency information that is influencing my intelligibility of that shoe impression. So what I'm going to do for this one is still the homomorphic filter, but I'm going to use a little different approach. First of all, it's very bright, so I'm going to turn this alpha down a little bit. But my high frequency contrast is actually very distracting to me. So I'm going to turn the high frequency contrast down because I'm not as interested in the differences between the pebbles, but I want to see this shoe impression. I want to see these overall shapes. So I'm going to turn my low frequency contrast up. Can the homomorphic filter also be applied to enhance low quality video in the background regions or pixels by nighttime? Ooh, that's a tricky thing because it would depend on, I don't know. I'd have to try. I don't think I've ever tried it in that instance off the top of my head. So I might try it, uh, but I don't know that the low resolution of CCTV video that you're probably thinking of, I don't know that the contrast points would be enough to benefit from this kind of adjustments. But again, that would be something worth testing for sure. So by turning up my low frequency contrast here to contrast to take away from the distraction of these pebbles and sand, I actually now can better interpret this shoe impression compared to where I started. So I see here I'm very uh, the these shapes are interfered with quite a bit by the gravel. And once I have this low frequency contrast higher than the high frequency contrast, I can see those triangles of the shoe impression and I'm able to interpret that detail a little bit easier. So on this one, I'm going to bookmark and call it number 8. Okay, great. Let's see. Oh, there you go. Thanks, Blake. Yeah, Clocky definitely is, I think, better for low contrast images because Clocky does a really good job of picking up on all of the detail for sure. Um, it emphasizes every contrast point that it can find. So that's a good call. Thank you, Blake. Okay, I'm going to go back up to one of these that I skipped or that I moved on from earlier, this number 6, because I told you I was going to return to it. This is another really good example for that homomorphic filter because I don't want so much the background. Oh yeah, it's like, why do I don't want so much the background, but I want those ridges. So I want this high frequency detail to be a little bit clearer and maybe turn this down just a little bit, turn the gain. And compared to where I started, it gives me a little bit more clarity in between just seeing contrast between the ridge detail and the background of this surface, paper, whatever this is. So now that this is a little bit clearer, I think I can hit my bookmark and I can call this one number 6. Great. And you might think, why am I bookmarking? It's all going to lead to something here in the end. If I want my images to be present in my report, I want to bookmark them. The information and all of the filters that I've applied to those images will always be in the report, but the images themselves are representative of each of my chains won't be present unless I bookmark it. So I'm just making sure to bookmark each of my chains once I am done with that process. Okay, now on to the Fourier as requested. So here I have another one where I'm going to start with a rotate because I want to be able to see it nice and easily. So I'll rotate it 90 degrees clockwise. It's pretty dark. I'm going to use my go-to levels, bring my highlight slider over, bring my shadow slider up, And now I'm using this information. In fact, I might even shift my midtones. I don't often do that, but I have a higher concentration of pixel values on the lower end of this range than I do on the higher end. So my midtone value is actually a little bit more towards this left-hand side. All right, so now I can see that I have ridge detail, but it still doesn't look that clear. And why is that? Because when I zoom in here, I see that this surface has this really repetitive pattern of these pinks, uh, yellows, and white dots on a blue background, I'm guessing. I think the blue is the background. When I have this repetitive pattern, it actually causes a frequency interference that makes it really difficult for our eyes to interpret the detail over the top of it. So we can utilize our frequency spectrum to isolate these frequencies and remove them from our image to take away the distracting element. And we do that with the Fourier filter, which is in the extract filter group. So if I go to Fourier here, it will change my image display to my frequency spectrum. Now, a regular frequency spectrum with no interfering frequency values would just look like an XY axis with a bright light in the middle. But if I look here, I see all of these other little starbursts that are all around the image. Those starbursts represent that frequency pattern that we're seeing in the background of our image. I want to go and select all of those and tell the software to essentially apply the inverse of those values so that we can cross cancel the interfering values. Now you can do that manually, or you can use this automatic selection button here, and it does a pretty good job of selecting a lot of those pixel values, a lot of those little starbursts. So I'm going to go from change my output from my frequency spectrum back to my image just so I can see how I've done. When I do that, I see, okay, maybe it's a little bit better. But when I zoom in here, I see, well, that's interesting. It's like we've captured the frequencies in one direction, but not the other direction, right? So we have diagonal lines that we've removed, but there are still frequencies here that are disruptive to our intelligibility of this print. So when I change this back to my frequency spectrum, I can look and see, well, maybe there's something that the automatic selection didn't get that I need to get. And as I zoom in here, I see, oh yeah, there's quite a bit of these starbursts that are close in to the center here. So they're going to be the most influential in that pattern response that the automatic selection didn't get. Well, I can supplement the automatic selection very easily by selecting, just drawing a box over these starbursts, and I can hit this add button. And you'll see in parentheses it says the letter U. Anything in 5 that we're going to add to a list, you can use the letter U as a keyboard shortcut. So I'll hit this add button the first time, but now I'm going to continue this process by using my letter U key on my keyboard just so it goes a little bit faster. I'll draw the box over the starburst. I will hit the letter U key, and you'll see that the software will automatically select the one I drew and its inverse up here in the top. And I can continue that process by drawing my boxes over the little starbursts. And with each one, I'm selecting this one, and the software is selecting that one as well as its inverse. So I can do as many of these as I feel like are bright, and then I can go back to my image and see if I've done a good job. So I'll go back to the image and see, okay, now the only thing that's left are these yellow dots. So I could possibly go back and continue selecting points until the yellow dots are also eliminated. But I don't think those are as disruptive to my intelligibility of the print, and I can see it a lot better already. I guess I could go back and see if there's anything else that's really obvious. I could do some of these other little points here. I just don't want to run too low on time. I want to make sure that we get through all the material, so I don't want to spend too much, but I'm going to do a bunch more of these little points just since I'm here. So again, I'm just drawing a little box and hitting my U key on my keyboard. I don't want to do too much. All right, maybe this one too. So now I'll go back to my image and we'll see how I did. And I still have the yellow dots, but I think it's a little bit better. And you might say, well, how do I know I haven't affected the print, the ridges? Because ridges are also repetitive, right? So we want to make sure we're not uh, damaging the print. So we give you also in this output dropdown the image complement, and the image complement is simply what we have removed. So I can see that I don't see any ridge detail, but as I zoom in, I see that it is the red and white uh, dots with that blue background that we've removed. So you can also keep this image if you're interested in presenting this to prove that you haven't removed any ridge detail. Uh, but I'm going to go back to my image and I'm going to bookmark this. And I will call it number 9. And I don't have to be renaming my bookmarks every time. I can rename them later, or I can leave them as the filter that I have applied. But I'm just doing that so that I don't get confused later, because otherwise you practice things a certain way and you just always do them that way. So that's what I'm doing. Okay. So let me look at, I have another one. We can go back to the number 2 that we did earlier. Number 2 is also a great example for the Fourier. So remember, we saw this one, we uh, rotated it, we made it brighter with the levels, and then we applied the white balance because it was a little bit green. And now when I look in here, I can see this is, I guess, the back of the check maybe, and it has that dot pattern to prove that it's an authentic check. Well, that's fine. That's not what we care about. We're not the bank. I don't know, maybe you work for a bank, but I'm not the bank. So I want to remove that uh, dotted pattern from the background. I'm going to do the same thing by using extract Fourier. And this one, the pattern is very subtle, but I can see it here. I'll try my automatic selection. And automatic selection for this image, for whatever reason, doesn't do a very good job of selecting very many points. So I will go and do the same process I did before, where I select the starbursts and hit my letter U key. And I think that's probably maybe this one too, and then I'll be good. So I'll go back to my image. And now I can see that the dot pattern is gone. And so my ridges are a lot easier to see the edges of. So let me zoom in here and show you, if I hit my show input, just how those dots were interfering with the ability to see the clean edges of the ridges. And once we apply this Fourier filter, now it makes it a lot easier to see what's actually the ends of the ridges and what is, the dots are not interfering with that. And again, we can look at the image complement to see that we've just removed the dotted pattern in the background. Great. So now that this one's done, I will bookmark this one as well. And I will call it number 2. Okay, great. Now we'll look at number 10. This one is, maybe something you might experience more with your regular casework. It's a weird patterned object. This image was the ridge detail was treated with a chemical and then photographed under a laser light, which is why it has this yellow cast. So I can treat it very similar to some of the other ones we've done. I'll rotate it just like I did before, 90 degrees clockwise, so I can see it without having to turn my head. I might want to just eliminate that yellow cast automatically by going through my channels and grayscale. So there's one way to now no longer be influenced by that yellow color. Then I can brighten it up just like we did before, bring that levels, that highlight point up, and those ridges are quite a bit more clear. But an interesting thing when it's photographed under laser light, if you're working on analyzing these ridges, you might notice that now instead of being dark like inked ridges, they're white uh, because they've been lit by that laser. So in order to have these oriented the correct way, we might need to invert this image and view it as a negative. We can do that easily with our extract filter as well. We have a negative filter here, which will make those ridges the correct orientation for your analysis. So now they will match. If you're comparing to an inked print, you would have dark ridges to dark ridges. All right. This one, we could also do that Fourier because there is this pattern here. But this one, I want to caution you. So I'll process it just the same way here, where I'll use that automatic selection, and it doesn't select anything towards the center here. Okay. It does select something out here at the end. So if I go in and say, no problem, I'll select all of these. Oh, that was not a very good box that I drew. Because that pattern area is only present behind the ridges and not throughout the rest of the image. Oh, that was another weird box I drew. That's what happens when I'm using a different mouse, but that's all right. The repetitive pattern is not present in the whole image, only right behind. And so sometimes you can be a little bit too strong. This time I think I did okay. But I am noticing just slight difference to the ridges themselves. So if I go to my image complement, I can actually see there's some smudging that appears where those ridges are. So I want to be really careful to not go too strong. So this is one of those where I might go back to my frequency spectrum and actually take, hello, back to my frequency spectrum. There we go. And I might go in and take some of these out, remove them, and make sure that when I go back, that my image is not being affected. So I'll look at my image complement again, and this is better. I'm not smudging so much. And when I go to my image, now I'm removing some of that pattern, but not affecting the ridge detail in the same way. So that's why we give you that complement. It's not just as a proof to show people, but it's also a check for yourself to make sure, am I over processing? You don't want to over process. You want to do only the right thing to make those ridges more clear. Okay, great. So now I will bookmark this one and call it number 10, and we'll keep going. Okay, where or after. Okay. How about a prior selection to calculate FFT of just that area? Yeah, that would be a really good suggestion. We don't have the selection box in this filter the way that we do in some of the other filters. I think it's just going to calculate all the frequency information for a whole image, but it's an interesting point to consider to maybe have the ability to use only a source area within the frame. That's a good question and something that I could certainly pass along to the team for further discussion. So I appreciate that. Okay, I have the next little transitional part here. So beyond talking about color channels, contrast, and frequency values, we might try to isolate actually components or specific colors within an image. This can be helpful in a lot of instances when you have um, interfering patterns, when you have lots of different colors that are um, distracting or interfering with your subject matter. So we'll go through these two here, component separation and color deconvolution, very quickly. Okay, so number 11. This one we use a lot to show you component separation. The way that component separation works is it actually maps the signal information within the image and separates the content into separate channels to the best of its ability. So within this extract filter group, we have this component separation. You'll see that once it is performed, you can separate into different channels here. So channel 1 in this instance is kind of like what's built into the surface of the paper. So you've got the grid, you've got this like crayon drawing mark, you've got the ruler. Um, channel 2 then becomes our ridge detail, which is really nice in this example. And channel 3 is kind of the dye stain on the paper, whatever that material is in the background. So this makes it very nice to isolate those ridges and move forward from here. So without having to do any other work really, I'm going to bookmark this one, call it number 11. I have another example of those that I made with these stamps. I'm going to use these stamps a couple of times, but in this example, we can use that same extract component separation, and it will do a really good job of separating these contents out for us. This channel 1 really does a good job of isolating these ridges for us. Channel 2 shows some of the printing of the stamps, and channel 3 kind of eliminates the borders of the stamps and just shows you the inked part. So, but that channel 1 does a really good job of isolating our ridges. So I will I could bookmark this. We could go in and do some more homomorphic filtering to make those ridges even stronger. But I think I'm going to just leave it at this and bookmark that just in the interest of time. This is number 12. But I will show you just as another example, if I had this image again, using that the under channels, extract channel that we talked about before, this does a very similar thing. In separating out the red channel, we get a lot of the ridge detail. And if we were to look at our green and our blue, we see different information similar to how that component separation worked. So this is also a really nice result for those particular images. Okay, this next one is another uh, component separation one I can utilize. So this one is really dark, but if I tried to make it brighter using levels right now, it would make it, you know, better. But I might try to uh, see if I can separate the components in this image and make it a little bit more clear. So I'll do that same component separation here. And when I look at my channel 1, I get just darkness, which is not helpful. My channel 2 ends up giving me my ridges, but they look, remember the laser light will make the what should be dark ridges to light. So this is that example there. Channel 3 um, shows me more my background. I can still see the ridges, but they're easiest to see here in this channel 2. So this is going to be probably the one that is the most helpful to me. I might have used that levels after here so that I can bring, I just am switching the order of my levels and my component separation, just so that I can utilize my levels, bring my highlights over here. Get out of here, bookmarks, you're taking up space. So that I can use this to make that black point a little bit darker. So now I can see my ridges nice and clearly. And here again, I might extract the negative so that my ridges are dark the way that I intended them to be for my comparison. Okay, let's look at the other filter that I mentioned, color deconvolution. So Do I want to do it in this one first? Well, we'll do it in this one first. This one is an interesting one because there is a tire impression. It's very difficult to see because of the pavement pattern here. So color deconvolution will allow me to say, what color do I care about? And I want the color of the tire impression. So I'm going to click in this dark area here, right? My first tab is desired color. So I'll click on that dark area of my tire impression. My next tab asks me an undesired color. So I don't want this tan color in the background. The next tab asks me, what's another undesired color you don't want? Well, I don't want this dark tan down here either. And what is the background color? So the background, well, I kind of said I didn't want the tan already, but I'm going to put this background here. And I get kind of mixed results with this image sometimes. Yeah, it ended up being a little bit extreme in the results. So you have to be a little bit careful where you pick. However, uh, I can see the outline of that tire impression now more than I could in my original. So again, here's my input. It's not super clear there. When I have applied this, it looks like it's weirdly blurred, but I can still see that my scale is nice and sharp. So I could do something like a sharpen or even the homomorphic filtering if I wanted, but in this instance, I'll apply an unsharp mask just to make those edges a little bit clearer so it's not, doesn't give the appearance of blur. Um, and here now I could use this information to compare to if I had a tire that I was comparing. I could at least see the pattern of how that tire is presented here in the pavement. So I'll bookmark this one. Number 14. I didn't bookmark number 13 apparently, but we're moving on. That's okay. Okay. The next one is an interesting idea, and I didn't put a slide specifically about it, but I'm going to just talk us through it. So let's say you have this image, and I apologize, this is kind of a low resolution one, but you have an image of there's ridge detail on this money. And no matter what you do, if you try to clarify this, it's going to be tough. If I tried to do component separation or something like that, it's not going to identify the ridges as a separate component really for me. It's a little bit difficult to isolate the ridge detail on this image. So I'm going to click here and delete component separation because that wasn't helpful to me. But what can be helpful is the fact that we know what this money looks like. This money is printed the same way every time or roughly the same way. So if I were to take another example of this same money, right? So I've got the money in one frame and the money in another frame, and the money is the same. I can take the values of the money and subtract them from my image. And if at each pixel value location, so let's say, for example, in this area here, these pixels have a specific value. And if in the other money picture, those values are the same, when I subtract one from the other, the value should be 0 or close to 0. Okay, and in my histogram, 0 is black, right? So in the locations where those values differ, I will get a non-zero number, which will give me some kind of brightness value that's not black, okay? So I can take these two and I can put them in a video mixer. Now, video mixer is going to default to the wrong inputs every single time. But I'm going to tell it what I want, which is the ones I just brought in, which are 15A and 15B. By default, it will put in your very first thing in your history panel and your very last thing in your history panel, which sometimes is what you want, but just make sure that your inputs are set the way that you want them to be here, okay? So I have these, the default is side by side, but I'm gonna go to the blend tab over here. And I'm going to subtract these from each other so that I can highlight only the things that are different. It's like I feel like this is something Blake would say. It's like my adult version of highlights, right? We're spotting the difference. I'm going to subtract one from the other in this mode here. The default is side by side, but I want to do the absolute difference between the two. I could subtract one from the other, but I'm just going to go with absolute difference. And you can see I have values where that scale is because I only had the scale in one of my image. And I have values where my ridge detail is. And everything else is pretty dark, pretty close to 0. Okay, so this is an option for isolating your ridge detail when you have it printed on something that you know. So let me give you another example. The video mixer works really well when you know the alignment is already properly calibrated, but there are times that you might not have those things already properly aligned. So let me give you another example. I told you I'd use those stamps again, and here they have come back, right? So the stamps are mass printed. There might be some variation in the stamps, but in general, they should be more or less the same from stamp to stamp. So I've got this ridge detail that's over this stamp, and it makes it a little bit difficult for me to see what's going on here. So I might want to remove the hearts, remove the stamp from this image. So I've got another image of just the stamp. Keep having things in front of what I'm trying to do, which is problematic for me. Okay, there we go. All right. So I've got my two images now, but as I go from image to image, you can see they're not exactly properly aligned. So if I were to subtract them from each other here, I wouldn't get a nice perfect subtraction because the stamp itself is not identically aligned. So I'm going to use a slightly different filter here, this perspective aligner. Perspective aligner is also going to default to my very first input and my very last input, which is not the ones I want, which is why it tells me they don't match. That's fine, I'll fix it. So in this instance, I want 16A and 16B. So now I have my two images properly loaded here in my first and second input. And in this instance, I'm going to go to the perspective tab, perspective. Okay, so in my perspective tab, it's asking me for matching points. So what I'm going to do is find some areas in my one image that I know I have present in my other image so that I can align them. So I'm going to start with, just something up here like this corner of the two, and I'll go over to my other image and find that same corner of the two. And again, just like my other filters, when I want to add something to this list, I can hit my add button or my letter U key. So I'm going to do that. It's important when you do these point matching that you always start on the same image and go to the other image. So I'm always going to start on this left-hand side and go to the right. So I'm going to do the point in this purple heart and go to the point in the purple heart over here, hit my U key. We'll do this point in the orange heart, go to my point in my orange heart over here. I'll come down and maybe do this point of the pink heart. Come over here and go to the point of the pink heart. And I will do the point of the purple heart and come into this point of the purple heart over here. Hit my U key. Maybe I'll do something down here at the bottom. So there's a question of whether you could use this when you're trying to compare two images of a person. I would really caution you for that because, and you'll see in just a moment, what I'm going to do is end up it's going to end up moving the pixels of one of my images, and I wouldn't recommend doing that for a face just because that can change the whole appearance of somebody's face. So what I've done is I've selected a number of points that correspond something from the left to the right. and I will uh, change my perspective on my second image. I don't want to distort my fingerprint, so I'm going to change my second image here, and it's actually going to move those pixels so that they line up. Okay, so that's why I caution you to use it for a face. But then under my display tab here, I have my same settings that I had in my uh, video mixer, where I can do that absolute difference between the two and isolate my ridges. And here, if I move my bookmarks again, down at the bottom, oh no, not too far down, there is a gain slider that will just increase my brightness a bit. All right, so I have uh, a couple of other things. Man, I really thought I was going to be struggling to fill the time, but now I'm going to be struggling to finish in time. There are a couple other things I want to make sure to point out to you. So um, the first thing I want to do is show you how you can calibrate an image to be one-to-one. This is a really important step for analysis of any type of comparison like this if you are able to calibrate a scale. Okay, I lost my place in my notes here, but that's okay. I will go back to number 3 is the one I marked that I wanted to do this in. Okay, so here we have in this image, we know what 1 inch is in the image, but right now this image is 2750 by 3981. What does that mean? That doesn't necessarily mean that 1 inch equals 1 inch in real life. So if I go to my edit and resize one-to-one, I'm going to be able to tell the software this pixel distance of 1 inch is going to be equal to 1 inch. So I'm going to go to my 1 inch line here, and I'm going to draw a point from the 0 to the 1 here. And I've gone to the bottom edge of that hash line just so that I'm consistent. And this says that pixel distance is 2576, and that equals a world distance of 1, and I'm going to change my unit of measurement to inches. The default is to resample. That's going to shrink this image so that that is actually 1 inch. That's not what we want in this instance. We want to embed the DPI metadata. Okay, so when I embed the DPI metadata, you'll see that my output DPI will go from the default of 96 dots per inch. Once I hit apply, it will become the output DPI that I've just specified. So that's an important consideration. Okay, that's resize one-to-one. Let me bookmark this one. That's fine. Okay, 2 other things to show you. And here's my again, move this out of the way, my real quick slides, because we don't really have time to go into as much detail about this as I was originally thinking. But steps 2 and 3, comparison and evaluation, right? So the analysis part is a large part of what we do, especially most of us as video and image examiners. I have not been a latent print examiner myself. Admittedly, I've worked hand in hand with them as their photographer, but this comparison and evaluation step, they're 2 separate steps, but visually I'm going to show them to you as one, just so that you can understand the way that it can work here. We can do it with annotating and marking up the features very simply in our annotate tool. And then that evaluation step is the point at which you or the examiner would be evaluating those features to determine whether or not they can be an inclusion or an exclusion at this point. So let me show you a very quick annotation of some features in a latent print compared to an inked print. So when I turn on my annotate tool here in presentation, there are lots of different ways that you can do this. I will show you a couple of ways really quickly. One being just a shape to mark things, right? So I'm not going to use red, that implies guilt a lot of the time, but let's use yellow, that's fine. And I might go in and mark up some of these features. So for example, here's a bifurcation. Wow, that's really thick. I want that to be thinner. So I'm going to turn my border thickness down a little bit over here. Here's a little ending ridge. Catherine has asked, what about when the source images are out of focus or overexposed? Those are things that you would address with that adjust or with a sharpen or the homomorphic filtering. Those are the things that help with those sharpness features for sure. Okay, just to make sure that I get through everything, I'm going to come back to the questions. Sorry. But I'm going to mark those three features. Here's a little ending ridge. Here's a bifurcation. Here's a bifurcation. That's something that I might mark. Then when I look at my inked print, I've gone through my 10 prints maybe, and I've said, okay, here's another one that's an arch. So I know that it can match this one. And then I might go in here and say, okay, well, I can look at these side by side by bringing my 19 out here and going to my maybe going to my end. We'll just do it this way. Nope, we won't because I have lost where I am in my history panel. There's my little arrow. Go, 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 go. 18. Okay. So I'll look for these same features over here and I can mark them the same using that same annotate tool, or I might do it. Let me show you a different way. I might do a frame size on this one where I can increase my frame. Oh, I did it on the wrong one. That's okay. We'll do it on this one. And I can use my annotate tool to draw an arrow to these things, like so. Maybe again, not red. Or I could say, oh, here is a feature that I want to magnify. Like maybe it's important that there's this weird scar that goes all the way across this finger here, because once I get over to this image, I can see the same, sorry, I can see that same scar and I want to present it the same way here. All right. And then using, if you remember when we saw our video mixer, those things were able to present side by side, and we can very easily show those images side by side. The last thing I wanted to show you, and I know we're right at the end of time, is just the ability to generate the report. I have to save my project, just put it in my webinar folder, that's fine. The report allows you to put your name, case number, date, everything you want on every single page. So I'll just put numbers there so that we can view this report. So you can see the information here shows the integrity verification for each of my images that I had loaded into my project. Down below, it will show a bookmark for each of my images that I bookmarked as I labeled them with the file numbers. Towards the bottom here, it will have each of the filters that I applied, as well as I mentioned, all the details, the parameters, and the white paper references here for each of the filters that has been applied in the chain. So this is very easily generated right out of the report, which helps to support the forensic nature of everything that we're doing here. So feel free to reach out to me, or you could email info@ampsoftware.com. That works as well.